graphing rational functions. Let's have an example. So, consider the function f of x equals x minus 2 all over x plus 2. So we need to find its domain, the intercept, and then sketch the graph. Then determine what is its range. So first thing to do is again construct a table of values. So if we have the given function is f of x equals x minus 2 all over x plus 2. So it is a rational function. So for the table of values, so let's have negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. So like as usual, we have to substitute the given value of x on the given function. So let's take f of negative 4. So x minus 2 over x plus 2. Substitute the negative 4. So we'll have negative 4 minus 2 and negative 4 plus 2. Then simplify. Negative 4 minus 2 is negative 6. Negative 4 rather plus 2 is negative 2. So negative 6 divided by negative 2 is positive 3. So we will have here positive 3. So like what we have done to find the f of negative 4, we will also do the same on the following values of x. So if we have x equals negative 3, we will have f of x equals 5. For negative 2, the denominator will become 0, so that is undefined. Then for negative 1, we have negative 1.5. For 0, we have negative 1. For 1, we have negative 0.33. For positive 2, we will have 0 for f of x. Then for f of positive 3, we have 0.2. And then for f of positive 4, 0.33. So we already construct the table of values. Next is we are going to plot this on the Cartesian to plot the points from the table of values. So the first points, negative 4, positive 3. So here. Negative 3, positive 5. So here. Negative 2, undefined. So for the undefined, we will not plot this point. Then for negative 1, negative 1.5. So here. For 0, we have negative 1. 0, negative 1. So here. Positive 1, negative 0.3. So here. then positive 2, 0 here, and then 3, 0.2, so here, then positive 4, positive 0.33, so here. Then we are going to connect. Then this one. So since the negative 2 is undefined, so we will have, this is also where the asymptote is. So we will plot the asymptote as broken line. So the graph will get closer and closer to the asymptote but never intersect. Is the vertical asymptote. So for now, we will find next the horizontal. The horizontal asymptote of a rational function. We need to consider the degree of the numerator and the degree of the denominator. So we're going to represent let n be the degree of the numerator and n be the degree of the denominator. So there are three cases. First case is if n, or the degree of the numerator, is less than the degree of the denominator, or the n. So the horizontal asymptote, or HA stands for horizontal asymptote, is y is equal to 0. Case number 2, if n is equal to m, or the degree of the numerator is equal to the degree of the denominator, the horizontal asymptote is y is equal to a over b, where a is the leading coefficient of the numerator. And b is the leading coefficient of the denominator. For case number 3, if n is greater than m, or the leading degree of the numerator is greater than the degree of the denominator, so there is no horizontal asymptote. So in our given rational function, we have f of x equals x minus 2 all over x plus 2. Our n is, on our degree of the numerator is 1, since the exponent on the numerator is 1. also in the degree of the denominator, 1 also our first degree. So same first degree. So that case is case number 2. That states if n is equal to m, then so given number 1 will fall on case number 2, where n is equal to m, or the degree of the numerator is equal to the degree of the denominator. So therefore, the horizontal asymptote will be y is equal to a over b. So our a here is the leading coefficient of the numerator. So the leading coefficient of the numerator is 1, since we have here only x. So the leading coefficient of x is 1. So we will have 1 divided by the b, or the leading coefficient of the denominator, which is also 1 here in the denominator. So our y, or the horizontal asymptote, 1 divided by 1 is equal to 1. So since our horizontal asymptote is y is equal to 1 in the graph, so y is equal to 1 here. So this will look like, we will plot a graph the horizontal asymptote. So here. So meaning the graph will gets closer and closer to y equals 1, but never here, but never intersect. So like here, gets closer and closer but never intersect. That's all. Thank you. So for the domain, so since we find out on the table of values that if x is equal to 2, the f of x will become undefined, so our domain will become all elements of x are real numbers such that x must not be equal to 2. That is for the domain. For the intercept, so our x-intercept is equal to positive 2. Then for the y-intercept, our y-intercept is equal to 1, since that is our horizontal asymptote. And then for the range, for the y-intercept, since our f of 0 is equal to 1, so that is equal to negative 1, so that is negative 1. Then for the range will be all element of y are real numbers such that y must not equal to positive 1, since our positive 1 is our horizontal asymptotes. That's why the range will never be positive 1.